Hey, you guys, welcome back. So, we are going to go into our next section here. It's actually two topics, and this is actually the end of level M for the math course, which means that we've gotten through about half of the content so far. So, that's great news. I think a few of you were actually sitting around this level approximately when we started, and so once we dive in next week, we're going to be getting into newer topics and going into some more things a little more in depth. Today, we're going to wrap up level M, and we're going to do this with a discussion about statistics and graphs and charts. So let's go ahead and get started. So our first topic is topic 5 of level M, and that is about graphs and charts. We're going to start this topic off by actually talking about tables first. A table is something that it's a two-dimensional flat thing you draw on paper that is used to organize data into different categories. Usually it's two categories, and you might have like sub options within those categories. And then tables can show you different types of information. Tables can show you the frequency, which would be the count, like how often something is occurring in a data set based on that particular category that falls into. It can also show you percentages of a total. So let's go ahead and let's just make some tables so we can kind of show exactly what they are, what they do, how you build them yourself. So first example, it says create a table with the given information. A class at school has 32 students. And then in that class of 32 students, there are 8 girls who play basketball and 5 boys who do not play basketball. And in total, there are 15 girls in the class. So let's talk about at first what our table is going to sort of look like. So I guess I'll just do black. That'll be fine. A table usually has a design like this, and then you need to add the appropriate number of rows or columns based on what your categories are. So it looks like our two categories here are going to be one, which is gender. We have boys and girls in the class. And then two, the other category, the other thing we're talking about that has to do with these students is whether they play basketball or not. Okay, so along the left side, we could put either the gender or the basketball, and then across the top we would put the other variable that we didn't use. So I'm just going to go ahead and put girls and boys over here on the side, and we need to make a row out of that. And then across the top, we're going to say plays. I'm going to have to abbreviate this as BB for basketball. And in here on the second column, we're going to put doesn't play BB. Now, obviously, I need to make my table a little bigger here to actually fit everything. Now, something else you have to keep in account too is that in tables you often have a total, and so we're going to make a total column. And we're also going to make a total row, so I'm going to have to make this just a little bit bigger to fit everything. And there we go. So, could I have made that maybe just a little more beautiful and refined, of course, but it's fine. This will do for this example. Let's fill in the data that we know. So what's happening in every one of these cells here is that you have some sort of intersection of the categories. So in the first cell, right here where my pencil is pointing right here, this number should be the girls who play basketball because I'm in the row for girls and I'm in the column of yes, they play basketball, okay? And then that would mean that in the second cell, the one I'm pointing to now here, I'm still going to be talking about girls, the females in the class, but this is going to be the count of the ones that do not play basketball, okay? So the first thing you should usually do with a table is fill in the information that you know that they gave you, and then you can sort of use that to work backwards and get the information they didn't give you. So they told us that there are 8 girls who play basketball, so there's going to be an 8 here. And they told us that there are 5 boys who do not play basketball, so that's going to be 5 here. And they also told us that there are 32 students altogether. So in this bottom corner, this number in the bottom right corner is always going to be the total of just everything. So whatever it is that you measured, which in this case is people or students, that total is going to go in this corner. They told us there are 15 girls total in the class. So in the row of girls right here, between the ones who play basketball and the ones who don't, there are 15 altogether. So we're going to fill that in here. Now, believe it or not, they gave us enough information to fill in all the other cells that we don't know. So I'm going to switch colors. We're going to use like blue, I guess, for this. So actually, let me spell that out. Let's really draw that out. So the red values are known or given by the problem, and then we'll use blue to say the ones that we're actually solving ourselves. So in a row, okay, if you have a total at the end of the row, all the things that are in that row that precede that need to add up to that total. So that means that 8 girls who play basketball plus some number of girls who don't play basketball has to add up to 15. So what would be the difference there? Well, it's 7 because 8 and 8 is 16, and I need to go 1 under that. So this is going to be 7. So I know for a fact there are 7 girls in this class who do not play basketball, because if there's 15 girls altogether and 8 of them do, then 7 must not. Now I can do some other things, like, for example, for the students who don't play basketball, this is up and down now. I'm looking at this column right here. For the students who don't play basketball, doesn't matter if they're girls or boys, because just in looking at this column, I'm kind of ignoring everything else that's in this table right now. I'm only looking at this column, right? If I just look at the number of students who don't play basketball, I know all the subtotals of those students, so I know the total altogether, which is going to be 12, because 7 and 5 makes 12. Now I can get some more information now. If I look at the total column down here, right? So the total number of students who play basketball, whether it's a girl or a boy, doesn't matter, right? The total number of students who play basketball plus the total number of students who don't play basketball is going to give me 32. Because out of my 32 students, 12 of them do not. So how many do play basketball? That's going to be 20. So now that I know this, I can finish this column right here. So out of my 20 students who play basketball, 8 of them are girls. So how many of them must be boys? That's going to be another 12 here. And then I can use this information to find my last total over here, because if I'm looking only at my boys, that's this row here, 12 of them play basketball and 5 don't, and 12 and 5 together makes 17. And if I add 15 and 17, I get 32, and so I know, just a little check there, I know that that one is correct. So they gave us these red values, and then we solved the rest of the values in the table, and our table is now complete because every cell in this table has information in it now. So the next question is very similar. We are creating a table once again. And this time it's a student named Felipe. He surveyed some students at his school, and they gave us some information here about how many have an iPhone and also how many have an iPad. And then there's some that don't have an iPhone but do have an iPad, some that don't have either one of those devices. So I'm going to give you, right, I'm going to tell you, let's write it in black. We're gonna step through this together to talk about what the 2 categories are, and then I want you to pause the video and attempt to do the table on your own, okay? So let's just talk about the categories, right? So the first category it has nothing to do with gender at all. They didn't tell us anything about boys versus girls, or males versus females. What they did tell us was they told us that they either have an iPhone or they don't. That's the first category. And the other category would be has iPad or doesn't. Okay? So the two categories being measured here are from every student that they surveyed, they asked them, do they have an iPhone and do they have an iPad? And the answer was either yes or no. And that's the categories. So using that information, let's make a table. And I'm going to just draw the shape for you, and then you're going to go ahead and go forward, right? It's going to look pretty similar to the one that we did before. This is your total. And this is your total row. And I want you to go ahead and kind of take a break, pause the video, fill in the rest of the information based on what the problem is telling you, and then when you come back, we're going to work on it together. All right, let's go ahead and finish this table. So let's use, okay, we're going to label this. So this is going to be, I'm just going to use check marks and X's to make it a little easier for me to fill this in. So across the top, I'm going to put yes for iPhone and no iPhone. And this is going to be yes iPad and no iPad. So you might be asking yourself, like, couldn't I have done it the other way where the iPhone was on the side here and the iPad was across the top? 100% yes, you can do that. It's up to you. As long as you keep the categories together, then you can put them across the side or the top. It doesn't make a difference. You're still going to have the information, organized the same way. So let's look at what we were given. We'll use red for the given information, and then we'll use blue for the solved information. So the given information is that, okay, there's a lot here, right? So 78 students have an iPhone. So the total number of people who have an iPhone will be 78. And then out of those 78 students who have an iPhone, 57 have an iPad. So that's going to go here because that means that they have both. They have yes iPad and yes iPhone. What else? 13 students have an iPad but do not have an iPhone. So this is going to be 13. And then 9 students do not have either. So no iPad, no iPhone was going to give me 9 right here. Okay. So now we need to fill in the rest of the information. So the first thing you might notice is that we know the total students who have an iPad. That is going to be 70 students. And then we can do the total of students who don't have an iPhone. That's going to be 13 plus 9. Let's see, 9 and 3 is 12, so 22. Now we know the total students, period. So that's going to be 100. So that's 100 students surveyed altogether. The total students who don't have an iPad is going to be 100 minus 70, which is 30. And then the last but not least is going to be this category, which is going to be 21. That's 21 students who have an iPhone but do not have an iPad. So there you go. The question this is asking you now is how many total students did he survey? And actually, we solved that pretty early on. It's 100. But you might be asked several different questions about the table, and so it's going to be a matter of not just filling it in, but then can you read the table afterwards when you're done. So that's the gist of how tables work. We're going to keep moving right along here. Tables are actually the basis for most of the charts that we create in math and science. Charts are visual representations of the data, And what they are just pictures or drawings. So you might see, you might be familiar with like pie graphs, pie charts. You might see bar graphs or histograms. You might see line graphs, and we're going to cover all of those today in this lesson. And we're just going to go bit by bit and create some. So a circle graph, or a pie chart, that's another word for that. A pie chart or a circle graph shows you the parts of a whole for a set of data. And what it can do is it can really help you identify pretty quickly just by looking at it without even looking at any numbers. You're not looking at numerical data, you're looking at a picture. You can really quickly and easily tell what category or what categories made up the majority of the data or what has the most data. You might also be able to tell what has the least amount of data based on a pie chart. So let's create a pie chart. This example says create a circle graph. A circle graph and a pie chart are the same. Create a circle graph that represents the types of coffee sold at Starbucks on a given day. If they sell 100 drinks total, and 37 of them are drip coffee, 22 are iced tea, 25 are espresso drinks, and 21 are frappuccinos. So you might want to make yourself a chart. You could make a chart if you want to. I'm not going to because I think this is pretty straightforward right here. But if there's 100 drinks altogether, first thing we need to do is we need to draw a circle, right? Okay, that was actually a pretty good circle until I got to this end here, and then it looks kind of flat, but whatever, we're going to go with it. So here is my circle, and let's say, for example, and I'm gonna end up erasing this, so if you don't want to draw this, that's fine, don't draw it. But if this represents 100 drinks, and I were to cut this like in half, and then cut that in half, each one of these 4 sectors here would be representative of 25 drinks, okay? So, actually, I'm actually not going to erase that. I'm going to leave it. So, and here's why. Because one of my categories is 25, right? So, if I'm going to just make this little corner here, and usually you color in the section, and I'm just going to use my highlighter to color this in. Nice and colored. Okay. So that doesn't look great, but whatever. So this section represents 25 espresso drinks. Okay? And that takes care of the espresso. Now we only have 3 more things to worry about here. The next thing I'm going to look at is I'm going to look at the iced tea and the frappuccinos because they're basically just under 25. And if I know that this one section like this is 25, I just need to go a little under that to make 22 and 21. So I'm going to make maybe like right here, and I'm going to turn this into 22 iced tea drinks. And then I need a section that's about the same size to go the other way. Now I actually am going to erase this. I'm going to get rid of these dots here because they're not really useful anymore. So that's going to be blue, and then I guess we could also use like orange and green. So another section might be approximately like this big. That looks to be about the same, and we're going to call this section 21 frappuccinos. That takes care of this. And then the last thing we're going to do in orange is going to be here. That's going to be 37 drip coffees. Okay. And then let's color them in. So we did a blue section. Here we go. There's our pretty blue section. We have an orange section. And we had a green section. Now, do you have to grab colored pencils and highlighters and markers and stuff and make these absolutely colored in and beautiful? I mean, you don't have to. You really don't have to. If you want to, for the purpose of your notes, absolutely go for it. I think it's a lot easier to visualize if the things are colored in. In fact, if you were to look at this right now, what would you say would be the category that had the most drinks? And I would say that the 37 drip coffees takes the cake there because this is the largest section of this circle graph. What's the smallest? Really hard to tell. It's really hard to tell. These three, I would look at this. If I didn't know the numbers, I would say that the three of those are about an even split. And if you think about this data, 21, 25, and 22, they're all really close together. And so I would go with that too, and I would say that it looks like an even split. But I would say for sure I know which one has the most, and that's going to be the drip coffees at 37. And that's it. That's a pie graph. Many times when you are tasked with creating charts, you can use tools like Excel or Google Sheets, and they do a majority of the work for you. But it's still important for you to understand the basis behind where these charts come from, because then you'll be able to tell if the graph that you made looks correct and represents the data correctly. So that's why we teach it. Okay, so the next type of graph you could have, and don't worry, we're not done with the circle graphs because I'm going to have you do this example right here. We're going to also talk about a line plot now, though. A line plot is also called a dot plot. That's another word for that. I'll use blue, I guess that's good. So a line plot is also known as a dot plot, just so you are aware of that. So a line plot shows the frequency of an item in a set, which is how often that particular thing occurs in a set of data. So let's read this problem so we can demo one. We're going to make a line plot that represents this situation. A survey was completed by 20 people, so there's 20 people altogether, and they took a survey, and the survey asked them about their TV habits. So 5 people said they watched no TV at all. 10 people said that they watch TV about 1 to 3 hours per week. 3 people said they watch between 4 and 10 hours. And 2 people said that they watch 11 or more hours per week of television. So here is what a line plot looks like. You're going to draw a straight line, and then we're going to put our categories here. So the first category is going to be 0 TV. They watch no TV at all. And then 1 to 3 hours will be our next category. 1 to 3 hours. And then we have, I think 4 to 10 was the next hours. And then 11 plus hours. And all you're going to do with this line plot or dot plot is you are going to make a mark or a marking on each category that represents the total number of times that somebody chose that option in this survey. So there were 5 people who chose the first option. So you're going to put 1, 2, 3, 4, 5. There were 10 people who chose the next one. So technically, I should put this in a straight line up and down. I think I will do that. For this to look correct, 6, 7, 8, 9, 10. For this to really look right, the dots should be the same size so that you have a good comparison between the categories. I drew this one a little smaller, so sorry about that. 4 to 10 hours was 3 people, so you're going to put 3 dots here, or 3 symbols or markings, and then there were 2 people who chose this category. Now, why would you ever do a dot plot or a line plot? Well, it's a really good way to show like a summary of the data and to be able to pick out, again, like the most and the least. So kind of a similar idea between the circle graph and the line plot. If you were to look at this, you should be able to pretty easily tell what category had the most people who picked that option and what category had the fewest number of people who chose that option. In this case, the 1 to 3 hours had the most choices, the most people picked that as an answer, and the 11 plus had the least amount of people who picked that answer. So I'm going to have you do a pause and try on this next question. We're going to create both a pie graph or pie chart or circle graph, whatever you want to call it, and a line plot that represents the following situation. 34 students took a test. The teacher has graded the test with the 34 students, and the students got the following grades. 9 people got an A, 7 people got a B, 12 people got a C, 4 people got a D, and 2 people got an F. So we're going to turn this into both things. We're going to make a circle graph and we're going to make a line plot. I want you to pause the video here and go ahead and create those graphs. Okay, so we're going to go ahead and do both these graphs. I do want to point out that on the circle graph, you can do it one of two ways. So, like, if you think of the circle as representing all 34 students, then each part of that pie, of that circle, each little chunk that you draw, each little sector, represents how many are in that sector, and all together they make up 34. But that can be a little tricky. It was easy the last time because we had exactly 100 pieces of data and we knew how much was supposed to go into each of that. And coincidentally, 100 pieces of data and 100%, it works out really easy for us. But that's not very easy when you have 34 students. So what we need to do is we need to make a little table that tells us what percentage of 34 is 9, what percentage of 34 is 7, what percentage is 12, and so on and so on. So let's make a table. We're going to put over here, we're going to put grade, and we're going to put percentage of 34. So for A, that's going to be 9 out of 34 times 100. And that's going to give us a percent. How much of 34, what percent of 34 is 9 pieces? I need a calculator for this because I can't do it in my head. It comes out to 26.5% approximately. How many were a B, C, D, or F? You're going to do the same thing each time. So this is 7 out of 34 times 100. And 7 divided by 34 times 100 gives us 20.5% approximately. We have 12 out of 34 times 100 is 35%. I'm not doing the math here, I'm just doing it on the side. And then a D was 4 out of 34 times 100, which is almost 12%. I'm rounding here. And then the last category is going to be 2 out of 34 times 100, which is about 6%. And all of this needs to add up to 100%. So we're just going to confirm that real quick. 26.5 plus 20.5 plus 35 plus 12 plus 6 gives me 100. So this is correct. Now I can really make this chart a little better, this circle graph. Let's draw our circle. Not bad. Okay, 26.5% is only a little more than 25%. So if you were to, once again, cut this into 4 pieces, right? If this whole thing represents 100%, 26.5% is going to be like a whole quarter of it, and then like a little bit more, okay? So that's going to be our A category. And then we have a B category, which was 20%. So it's going to be, if this whole thing right here is a quarter, 20% is like a little bit under that. It's like right here. So this is our B category. 6%, okay, let's think about this. If 20% is right here and this whole thing is 25%, then 6% fits right almost into this. You can actually just make it a little bigger, and that would be our F category, because that's about 6%, 20.5%, 26.5%, and then we have 35 and 12 to make up the rest of this. 12% is pretty small. We'll make that like this much. And then this will be our C's, and this will be our D's. So can you tell by looking at this what has the most? What grade was the most frequently occurring grade? It's the C, right? Because the C takes up the most amount of space inside of this circle graph. And I can actually get rid of all these extra little marks because they're no longer useful to me. I don't need to know where the quarter splits are anymore. Also, I messed up my F. There we go. Okay. The other thing we were tasked with doing was making a line plot. So here's my line, and then I'm just going to put A, B, C, D, and F to represent my categories, and then we're going to draw some dots for each one. There were 1, 2, 3, 4, 5, 6, 7, 8, 9 people with A's. 1, 2, 3, 4, 5, 6, 7 people with B's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people with C's. 1, 2, 3, 4, and 2 F's. So you can also look at the line plot and tell that the C's had the majority. The next highest was the A's, and the B's were pretty close too, and then not many people got a D or an F. And you can extrapolate that information from either one of these pictures, actually. So they're really both saying the same thing or telling the same story. Okay, so moving along, the next thing we're going to talk about is going to be bar graphs. Bar graphs can be either pretty simple. They can show like one category of information, no further breakdown, or they can show a breakdown of data but split across different days, like categories within categories. It just depends on what you're measuring, and then you're going to show that on the bar graph. So this is another way to show the frequency of data or how often something occurs in a particular set of data. So we're going to make a simple bar graph. A researcher goes to a public store and stands outside the entrance. As people come up to enter the store, he asks them if they are a Democrat or a Republican. And there's also an option where the person can just refuse to answer. So keep that in mind as well. So in one day of standing outside the store, 25 people responded and said they were Democrats. 28 people said that they were Republicans. And then 42 people refused to participate. So we're going to make a graph that shows this. The first thing is that on a bar graph, it's always going to kind of look like this. Okay, that's your general shape. Across here on the left side, up and down, you're going to be showing the frequency of how often the stuff on the bottom is occurring. So your frequency goes across the side, up and down. And then the categories, the categorical data goes across the bottom. So we're only talking about one day here. So we're going to have Democrat, Republican, and refused. I'm just going to use D, R, and refused to demonstrate that. And the frequency, so you have total control over what this graph looks like. If you want to put the highest value that this graph is going to show as 100, then that's fine. You can absolutely do that. In fact, I think maybe we should probably do that. No, I think the highest value was 42 out of these three categories, so maybe 50 would be a better place to put the highest range here. So halfway down from 50 would be 25, and then down here would be 0, okay? That's the gist of what you're looking at with a bar graph. Now remember, I said you have control over this on the side here, so you need to choose a scale you need to pick values on this side that match the data that you're working with. If you have a category that goes higher than 50, then that bar, let's say for example, this was like 100 people that said no, that goes above this 50 here, and so this 50 might not be the best place for you just to have that cap at. So if our Democrats were 25, I'm going to just draw a bar that goes up to 25 and then comes back down. Typically, you want to color that in or something so it looks a little prettier. You also have Republicans, which was 28. That's going to be a little higher than 25, but not much higher. And then you have the people who refuse, which was 42, and that's much closer to 50. It's probably like here-ish, okay? That's the number of people who refuse to answer the survey altogether. So that is a bar graph, plain and simple. Really, the only thing that is variable about this is you choosing the scale on the side here. You get to pick the scale that fits your data the best. And you can also look at a bar graph and answer some questions. So if I said to you, if you were looking only at this bar graph that we just drew, is it fair to say that there were more Democrats than Republicans? And the answer would be no, it's not fair to say that, because you can clearly tell that there were less people who responded Democrat than there were Republican. And what if I were to ask you, is this a fair representation of people in general? You might say maybe yes, because of the people who responded, these values are pretty close, and maybe you think that there's a pretty even split in our country of Democrat versus Republican. I would actually argue that this is not a fair representation, because 42 people didn't respond at all. They said, no thank you, I don't want to participate. And so without knowing what their answer really would have been, it's really hard to tell if this is really accurate or not. That's just another conclusion you can draw from this particular picture. So that's the gist of a bar graph. We're going to do another bar graph now on the next page of these notes. And on the next page on this next bar graph, we're repeating the same experiment, but we're doing the experiment across several different days. So now our bar graph is getting a little bit more confusing. All right, so let's roll this down. We're going to go to the next page. We're going to make a more complex bar graph using the same Democrat-Republican example from above. Let's say that this researcher repeats the same experiment 3 more times, so we have 4 days altogether. The results of his experiment are shown in the table below. So on day 1, we knew that there was 25 Democrats, 28 Republicans, and 42 people refused to answer. Day 2, here's the results of those 3 categories. Day 3, the results, and day 4, the same results. So what we're going to do is organize this information into a bar graph. We're going to use the number of the day across the bottom of our bar graph, and then we're going to actually have 3 bars for every day showing Democrat, Republican, and refuse to participate. So I'm going to use black first to do this. Here's this, and we have day 1, 2, 3, and 4. Now my question is, what should we do for the frequency along the side of this table here? So I think the highest value here was 42. And so I'm going to actually switch it up a little from before, and I'm going to make the maximum here be 40. And the bar that is going to be 42 is just going to be a little higher than that. That means that if this is 0, this is going to be halfway to 40, which is 20. Halfway to 40 from 20 is 30, and this halfway point is going to be 10. Okay? Now, this is where it's going to get a little complicated, because you're going to have 3 bars for every day. On day 1, you're going to have a bar for Democrats, a bar for Republicans, and a bar for refused, and then the same for all the other days. And so the best thing to probably do here would be to make a key or a legend, because every blue bar that I draw is going to be Democrat, every red bar that I draw is going to be Republicans, and then every, let's say, orange bar that I draw is going to be refused. And this is how we show subcategories of data on a bar graph. Because on every day is a category of the data. Day 1 is a category, day 2 is a category, and so on. But on each day, you can further break the day down by showing the Democrats, Republicans, and refused. So let's get drawing. The first, where's my drawing here? I'm going to do blue. Okay, the first day we had 25 Democrats. We'll fill in that bar. And we had actually a pretty close number of Republicans. And I'm like estimating here. I mean, this is like close enough to 28. You know what I'm saying? Fill this sucker in. And then for the orange, you have refuse, which was 42. We already know that one's going to come off the chart a little bit. And I'm not doing the best job in the world coloring this in, but I think you understand the gist of what I'm trying to say here. And that is my first day. My first day has 3 bars. My second day, third day, and fourth day are also going to have 3 bars. So I'm going to do day 2, and then you can pause the video and do days 3 and 4 and see if you come up with the same answer. So day 2, we had 29 Democrats. That's almost 30, so we're like here-ish. I might color them in after I draw them. Next color is Republicans. We only had 11 this day for some reason. A little strange. And then we had 20 people refuse to participate. That's like right here. And now I'm going to color the bars in. I could be using my highlighter for this. That might make it a little easier. I keep having to like switch colors back and forth, but it's cool. There you go. And our blue. Okay, now you can pause the video, and when you unpause it, you're gonna see the other 2 filled in. I want you to go ahead and try those yourself and see if you get the same, approximately the same looking bars as I do. Okay, here's my other 2 days filled in. Now, the question is a graph like this, is it helpful to you at all? I'd say the answer is yes. I think there's certain things that you can tell about this. We can tell the day that we had the most Republicans pretty easily. That would be the 4th day, because that's the highest red bar. The day we had the most refusals, that was the 1st day. It's definitely the highest bar overall anyway. And then the day we had the most Democrats, that would be day 2. It would seem to me that on average there were about the same amount of Democrats every day except for the last day. And then for the Republicans, I would say that for 2 of the days the numbers were pretty down, and the other 2 days, that would be day 1 and day 4, those red bars were higher. Now, what I can't say about this is I can't really say anything about reasons why it might have been one way or the other. I can speculate. I can make all kinds of inferences about what I see in this data here, but without it actually being told to me as something that's true or false, I can't say for sure one way or the other. This could be a Publix location that's in a pretty moderate area. It could be a Publix location in an area where people don't like to be bothered by people who are researching things at Publix. There's lots of different things you could say about this data. The things you can say for sure are the frequencies and the counts, because that is what the data is showing you. It tells you every day approximately how many of each of these categories there were in that bar graph. That's the only thing you know for sure. Everything else is just an inference, is just something you're extrapolating or guessing based on the data. Okay, I think we have two more kinds. Yeah, we have line graphs and scatter plots, and then we're going to start talking about statistics. So, for line graphs are pretty good at showing the trends in data. Um, and so, on a line graph, you're only going to have two categories shown there on the left and the bottom side of that graph. And they show things over time. So a really good example could be like stock values. Like you might have a particular company that you bought stock in, and you keep the stock for 10 years, and you want to look every year at what the average value of that stock was. If you have a chart like that, then you can look at that and say, wow, this has really gone up in value over the years, or wow, it's really stayed the same, or wow, the value has really gone down since I bought it. Maybe I should think about selling it. Um, you could also use it for a dozen other things like population growth or decline. You could use it for something that's going on, a current event in our world could be the coronavirus, the COVID-19. You could look at a line graph that shows the number of active cases in a city based on a certain number of days or weeks, and that would give you an idea of whether it's going down or going up. I'm going to give you an example of a line graph that has to do with population. This is the population of the city of West Palm Beach over the last 10 years. These numbers are absolutely not historically accurate. The 2019 number is where I started, and that was like 119,000 something, so I rounded it. And then I just made up numbers for all the other years. So this is not to scale. I'm not saying this is what the actual population was. I'm just using these numbers as an example. So again, on this line graph, we're going to have on the left-hand side the frequency, or in this case, it's going to be the population. So this will be the population. The highest value is 120,000. And should I go all the way down to 0? Probably yes, because there could be 0. We'll make this 0. Halfway would be 60,000. Halfway up here would be 90,000. The K stands for thousands. That's what I'm drawing there. And we'll kind of estimate and go from there. Let's see. This is 10 years, right? So this is going to be 2010, 2011, 12, 13, 14, 15, 16, 17, 18, 19. Let me just fill in the rest of my frequency here. 15, 14, 13. Okay, so we have all 10 years, and now we're going to plot the points. So in 2010, the population was 89,000. So we're going to put a point here. In 2011, it was 90,000. So it's only like right slightly above that. It's right next to it. Then we jumped all the way to 99,000. I probably honestly need to break this down a little further here. So if I were to cut this in half, right, there's 30,000 here. So this is going to be 105. Let's keep drawing. In 2012, we were at 99,000. That's maybe here-ish. In 2013, 102. Oops, that's not directly above. It should be a little closer over here. My bad. In 2014, and so on and so on. Okay, so I could draw the rest of these dots. I'm going to do that real quick. 14 is 105. 15, 109. 16, 111. 112. 115. Last year was 120. Now what you would do is you would connect all the dots that you just drew on here. So this kind of goes here and then up, 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 and there you go. That's a line graph, okay? Notice how there are no values down here at all under 60,000, okay? So something I could have done to make this a little easier to read was I could have just cut this entire bottom half of the graph off and started my scale at 60,000, and then you'd be able to see those subtle changes in the population a little easier. But really, my overall question is, what's the trend here? Is the population growing over time? And the answer is yes, it's growing, because it's going from left to right. It's going in an upward direction like this. If it was going down, then it would be going from left to right in a downward direction. And if it was staying pretty neutral, about the same, it would basically be going across in that direction. And that leads me to the last part of the charts topic, which is about scatter plots. Scatter plots are something that try to show if there is a relationship between two different things. So the first thing you should always ask yourself on a scatter plot is, how close together are the points? And are they going in a particular direction, either up or down or staying the same, in the direction from left to right? So I'm not going to make you plot scatter plots, because typically you have data points on there and you have hundreds and hundreds of data points in a scatter plot. I'm just going to show you some scatter plots and talk about the correlations. So the first thing is that on this first scatter plot, the data points they're pretty close together. These are not spread out all over this chart. They're pretty close together. And so because they are pretty close together and they're going in this upward direction, we say that this data has a positive correlation. It's positive because it's going in this direction, and there is a correlation because the data is close together. The second example I'm going to show you is this negative correlation. Once again, all the dots that are on this chart are close together to each other, so they're definitely correlated. And the question is, does it go in a positive direction or does it go in a negative direction? In this case, they're going down from left to right, so there is a negative correlation there. And then finally, we have a bunch of data. The plots, the points are just kind of all over the place. They're not packed tightly together. So there really is no correlation here, and you can't even say positive or negative because there is no correlation to start with. You couldn't draw a line through that data and all the points were pretty close to that line, like in the first two examples. If I were to draw a line here, yeah, there's a couple points close to that, but there's all these other points that are nowhere near the line. So there is no correlation in this data at all. And we're going to talk actually right now about what I mean when I say correlation and causation. Okay, it looks like once again my lovely my notes have frozen, so let's reload them so that we can unfreeze that. 1 second, we're just reloading that notes document. Here she is. Okay, we're gonna roll down. Okay. What I just said to you about variables is actually at the end of the next topic. So let's skip down to the end of that now and talk about that. So variables are things that are unknown. I am right here right now about the variables. Variables are things that are unknown and they can change in value, okay? So think about an example of things like variables, right? Like you are planning a vacation or a trip, and how many different things are there that you have to consider about that trip that could change or be different values or variables? You might be thinking, one, how much time can I get off of work? That's going to affect where I go on my trip. What's my mode of travel? Am I going to drive or fly or take a train? That affects how much time I can actually be on this trip. What's the cost of the hotels that you're looking at? Because that might affect how long you're going to stay there, because a cheaper hotel might mean that you add a couple nights to it because it's, you can afford to do that. Or a more expensive hotel might mean that you only go for 1 or 2 days. So those are all, and the weather too, the weather of the place that you're going, that could be a variable you have to consider as well. All those things are variables. They could change. And in math and science, we typically examine the relationship between two variables at a time. because it's really hard to measure something when there's all these different variables involved. So in math and science, typically you have two variables at a time. One of those is called an independent variable, and the other is called the dependent variable. And if you ever forget what these mean, I remember when I was in like elementary, middle school, and we were talking about independent and dependent variables, like I just, for whatever reason, I could not wrap my head around what the difference was and how to remember the difference between the two of those. And it finally clicked for me that you have to think about what the definition of those words are. So when you're talking about an independent variable, let me grab my highlighter here. The independent variable, right, is the thing that you have control over. Nothing affects the independent variable except you. You have control over this. In this example I'm going to give you, we're talking about fertilizer that you put into the soil. Nothing affects that except for you. You are in control of whether you put a tablespoon of fertilizer, a whole pound of fertilizer. You're in control of how much you're putting into that. But what does matter is the dependent variable, because it depends on the independent variable. The amount of growth that you get out of those plants depends on how much fertilizer you put in the plants. And that right there is the relationship between the two variables. Now, there could be other things that affect plant growth, right? It's not just how much fertilizer you put in, although that's something that we often look at. So there's other things that come into play, and that could be the amount of sunlight the plants are getting, right? Because plants depend on photosynthesis to make energy. So a plant could grow with a lot of sunlight or not a lot of sunlight, depending on what type of plant it is. Another thing you could think about that could mess that up for you would be the amount of times that you watered those plants. It could be a plant that needs a lot of water and you didn't give it any water, so it doesn't matter how much fertilizer you put in, that plant is not growing, okay? Or it could be a plant that doesn't need a lot of water and you put a ton of water because you were mistaken about it, and because you overwatered that plant, now it's not going to grow at all. And again, it's not going to matter how much fertilizer you put, because the thing that mattered here was the water. But really, in real life, isn't it a combination of all these things that could make a difference? So, that's where we get into the idea of confounding variables. A confounding variable is something that you didn't account for or didn't measure or put into your experiment, but it makes a difference. It affects the outcome. You could have, let's say you're in a laboratory, right? You're in a completely controlled laboratory environment. We're not talking about the outdoors. You have a simulated light that simulates the sun. You know exactly how much water you're supposed to put in these plants. You put the exact amount of fertilizer and put the exact amount of light, because it's been proven before from other experiments. So you know exactly how much you need of all those variables to control the growth of that plant. And then you leave the plant alone for a week to grow in a little lab environment, but you don't go back to the lab for a whole week to check on its on how much it's grown. You get back a week later and find out that even though you had all the right sunlight, all the right water, all the right fertilizer, the plant didn't grow at all. And then you find out that the power went out in the laboratory for the whole week that you were gone. And that affected the plant growth. That was something you could not have even anticipated. That is a confounding variable. Look up the word confounding and you will see that something that confounds is something that mixes up or messes up or confuses. And so that's where that comes from. It just messes up the whole outcome of the experiment. There's one more thing to talk about with independent and dependent variables, and that is correlation and causation. So you can pretty much always look at two variables and see if those things are correlated. And that means that there is some type of relationship between the independent and the dependent variable. So once again, let's talk about the plant growth, right? There you could see a graph, okay? and let's draw a little fake graph real quick down here of, let's do plant growth, and let's do amount of fertilizer on the bottom here. So let's say we put 1 pound of fertilizer, and let's say instead of that we try 2 pounds, and instead of that we try 3 pounds. Okay, and with this plant growth, right, with 1 pound of fertilizer, we see the plants grow about this much. With 2 pounds, we see the plants growing about this much. And then with 3 pounds, we see them growing this much, okay? Now, looking at this graph, and only this graph, right? Let's look only at this stuff. I'm trying to make this little, there we go. I made that thing go away. Look only at this graph right here, okay? You might be able to reasonably look at this and say, oh, well, that's easy. In order to get the plants to grow more, you just need to put more fertilizer, okay? Just because there seems to be a relationship between the amount of fertilizer and the plant growth does not necessarily mean that you have causation, okay? Not in every circumstance is it that because you add more fertilizer, you get better plant growth, okay? There could be other things that come into play like we just talked about. It could be, the water and the sunlight, for example. And so what we say usually when we're talking about statistics is that there just because there is a correlation does not mean that there is a causation, and that is what that statement means. This is an example of that right here. So that's what I wanted to tell you about variables, independent and dependent. And the very last thing we're going to talk about in this lesson today, these notes, are going to be the 3 different measures of center. If you see here, it's only this little section of this page. That's because there's only 3 of them, and they're pretty easy to master. So let's go ahead and dive right in. We're talking about measures of the center of the data. Now, that's not going to make a whole lot of sense today because we're not into all of that yet. But there's 3 measures of center. There's a reason we call them measures of the center. We'll get to that later. But all you need to know for now is what the 3 measures are and how you use them. So the first one is the mean. Altogether, you have the mean, the median, and the mode. Median and mode right here. We're going to talk about the mean first. The mean is the average of the data. You find that by adding up all the values you have and then dividing them by how many values that you added up in the first place. So let's do an example. We're going to do 2. I'm going to do 1 and you're going to do 1. The first one is find the mean or average grade in a class on a recent test. 12 students took the test and their scores were as follows. So I already know that there's 12 scores. And I know what all the scores were, so I know what every individual student got. But what I'm more interested in knowing here is what was the average. How did most students score on the test? What was the average score of this test? And for me as a teacher, that might actually help me decide if in the future I need to make this test a little simpler, or if I need to make it more difficult because most kids got a really good grade. I mean, it all depends on what it comes out to. So I'm going to go ahead and draw the entire formula out for you. You're going to need a calculator for this. So pull one up on your cell phone or grab a calculator you have handy. Go online and pull up a calculator. Google has one. You're literally going to do 72 plus 85 and 86, 91, 94, 71, 65, 42, 95, 94, 96, and 100, and divide all of that by the number of tests you have, which in this case is 12. And so I'm going to have to use a calculator for this. Pull one up on my computer screen real quick. 91, 94, 71, 65, 42, 95, 94, 96, 100. And all of that divided by 12 gives me approximately 82.58. That was my average score on this test. So overall, if I were to say something about this group of students, there's 12 students who took this test, the average score was an 82. Most people scored somewhere around an 82. There were some people, obviously, who scored much higher than that. I can see some 96s, 100s. There's even kids who scored really super low, like this guy who got a 42 and this one who got a 65. So that's not to say that every student got an 82. It's just saying that the average or the mean score was an 82. So the next question says, find the average cost of milk or the mean cost of milk. A researcher goes to 10 different stores and writes down the prices of 1 gallon of milk at each store. So what you're going to do is add the values up and then divide them by 10 and tell me what your mean is. Go ahead and pause the video and go ahead and do that now. Okay, so you should have gotten an average of $3.74. It's actually, on my calculator, it came out to 3.743. But we know that when you go to a store and you do dollars and cents, you don't ever do more than 74 cents. You don't do like 74 and 3/10 of a cent. There's no hundredths of a cent that we ever pay in our dollar system. So I'm just rounding that. I'm rounding it down to 3.74, and that's fine to do that. Okay, the next thing is the median. Rolling down here, and then we're going to talk about the mode. The median is the middle of the data, okay? You can remember the median because it's also a word we use to describe the middle of the road, like that concrete structure in the middle of the street when you're driving. That's the median, it's in the middle. So, and you're finding the median of the data, you need to sort the data. Okay, I'm going to highlight this so that it's really emphasized here. You always have to sort the data from least to greatest before you find the median, okay? Otherwise, you're not finding the true middle, okay? And then you're just going to count from outside towards the inside, and I'll show you what I mean by that when I write this data down. If you have an odd number of data pieces, so if you count these values and it's an odd number, you will find the exact middle. If you have an even number of data pieces, then you're going to have to average the middle to find the median, and I'll go through that with you right now. So first thing, let's find the median. First thing I have to do is put it in order. So the smallest value seems to be 8 here, and I have 8. I have another 8. Notice I'm crossing these off as I go so I don't get myself mixed up. And then I have another 8 after that. That's goodbye. And the next thing would be 9. I have 2 9s, so 9, 9. I have a 10. I have an 11. I have 2 12s. 12, 12. I have 1 13. I have 1 14. And I have 1 15. Okay, so now my data is in order from smallest to greatest. And yes, you include the repeats always. So now when I count from the outside in, you are literally going to just go to the outside and count off one at a time and make your way towards the middle. So 8 and 15, we have 8 and 14, we have 8 and 13, 9 and 12, 9 and 12, and then we have 10 and 11. Okay. So we have 2 values in the middle here. And altogether we have 12 values of data. So I knew this was going to happen because I have an even number of data points. So when I get to the middle, I have to find the average of 10 and 11. So 10 plus 11 and then divide that by 2 is going to give me 10 and a half. Therefore the median is 10 and a half. The middlemost value is 10.5 or 10 and a half. Okay, so now I want you to try this next example with this median. Make sure you put the data in order first from least to greatest, and then count from the outside in, and then you will find that median value. And you pause the video. Very good. Okay, so you should have found 11 to be your middle value. That's your median. You don't have to find any averages or anything because you have And even no, I'm sorry, you have an odd number of data points here. You have 13 data points, and so you had the same number of things you crossed out on both sides until you arrived at this one middle point. Okay, the last thing we're talking about is going to be the mode. The mode of the data is the most frequently occurring value. So you have a choice here. I know I wrote you should put the data in order first. You don't necessarily have to do that if you have a small enough data set. Usually you can tell, like just by looking at this list, what thing it is that is occurring the most. But if you want to get really, really into it, let's go ahead and write the whole list out, okay? So I think we have the same list as before, which was 8, 8, and 8. Bam, bam, bam. And then we have 9, 9, 10, 11, 12, 12, 13, 14, and 15. It's the same data set from above up here. So now I have them in order, and now that they're grouped, I can sort of see a little easier what value is occurring the most number of times. 8 is here 3 times, 9's only there twice, and 12 is only there twice. So 8 is the most frequently occurring. The mode is 8. That's the most frequently occurring value. Now I want you to do the same thing again with the next example. Put this in order, or just look and see which one shows up the most number of times, and you will find your answer. Just by looking at this, I can see that 29 is in here 4 times, and no other number seems to show up that many times. So the mode for this one is going to be 29. Okay, so that is it for this lesson. We've gone through this entire notes document. Next steps for you are going to be to check out the Delta Math. We're going to have a couple problems on there for creating some bar graphs and finding things like the mean and median and mode. And then make sure that you are logging into Essential Ed and progressing yourself past this level. After tonight, you should be completely done with levels. What did we start with? E. We started with level E, so we finished that like last week or the week before. And then we're now going to be finished after tonight with level M. So you should be done with both of those levels. And if you're not quite there yet, you need to get in there and just get those done, because we're picking up the pace now. We're doing about 2 lessons every single night so that we can progress through all the content and get finished with this course. And that's that. So if you guys need any help or anything, you know where to find me. Just check me out. And until I see you guys next time, have a great rest of your week, and see you next week. Bye-bye.